Hello again, it's 7.2 Reaction of Metals with Water, Chapter 7, page 134. I hope you watched 7.1. So, reaction of metals with water is very easy. As we said in 7.1, there is a general equation. So, when metals react with water, normal water, not steam, they make metal hydroxide and hydrogen gas is being released. So metal plus water, arrow, metal hydroxide plus hydrogen. That's called the general equation. It's just what happens to all metals if they react with water. So what happens when potassium react with water here? It's as being more reactive than sodium and lithium. Yes, because if you remember, first of all, it's the first in the reactivity series, so it's the most reactive among all of them. And also from chapter 6, we said that the more you go down the group, the more the reactivity, or the more the reactivity of the elements. So potassium is more reactive than both of them. So it reacts violently with water to form potassium hydroxide, and it will release hydrogen gas. The potassium darts about on the surface of the water, so it will just keep spinning, keep moving on the surface of the water. On, like, you see those small circles of flame? Yeah, they look like small meteors. Yeah, I don't know. Yeah, it looks like a meteor. It's potassium. Potassium, if you take it from the oil that's stored in and you just place it in water, that's gonna happen. And so it will release heat, so it's also exothermic reaction. So potassium plus water, arrow, makes potassium hydroxide plus hydrogen. The potassium, oh yes, the exothermic reaction gives off so much heat that hydrogen gas produced catches fire. So why there is fire here? Because of the heat being released from the reaction as its exothermic reaction, and the hydrogen catching fire. Because there's also hydrogen being released and it catches fire, and it starts making its own pop sound. If you remember, to test for hydrogen, you need to use a lit splint or a glowing splint, and it will make a pop sound if there is hydrogen gas being released. So in the periodic table, the alkali metals belong to the first group, while calcium is in the second group. Does calcium react more or less vigorously with water than alkali metals? No, it's actually less. It reacts less than them because the alkali metals are the most reactive metals. So group 2, they are less reactive. So let's take a look here on calcium reacting with water. It's so simple. This is a piece of calcium, this is water, drop it here. That's it. That's how you start the reaction. So it's add a small piece of calcium to half a test tube of water. Just calcium, put it to half a test tube of water, and what's gonna happen is the calcium will start reacting with water, forming bubbles. Bubbles is gas. Gas, you can guess that it's hydrogen because the gas being released should be hydrogen. And you can guess the other thing should be formed. Yeah, it's calcium plus water, right? So it should be calcium hydroxide plus hydrogen. Is that what's going on here? Yes, it is. It's calcium plus water, arrow, calcium hydroxide plus hydrogen. Please, when you write the word equation, just write it in words. Make sure to add the plus, make sure to add this arrow, make sure that the calcium and water are as reactants on the left side, and the calcium hydroxide and hydrogen are products on the right side. Oh yes, you place it in the water, it starts reaction. Now you have two things. Now I'm telling you that there is calcium hydroxide and there is hydrogen being released, but how do you confirm it? How do you make sure that the test is really going this way, or there is really calcium hydroxide being formed, or there is really hydrogen being formed? How do you know? Actually, to test for hydrogen is so easy. You're gonna just use this. This is lighted splint, or matches, or lead splint, or like any like small fire producer. So a lighted splint, when you place it on the top of the test tube, while the bubbles are being released, not after the reaction, while the bubbles are coming out, it will make pop, pop. It's literally pop, pop sound. So this pop means that the gas is hydrogen. So we confirm that there is a hydrogen gas being released. Okay, how can I test for calcium hydroxide? How can I make sure that really calcium hydroxide is formed, is a product in this reaction? If you remember, we did this in the lab. We used a universal indicator. It could be like any indicator that shows the acidic and the alkaline. So the hydroxide, any hydroxide is alkaline. So it should be here, pH more than 7. From more than 7 till 14, it's alkaline. So if you add the universal indicator drops and the color of the calcium hydroxide solution changes into dark green, blue, purple, any color of those, the alkaline part, that means that the calcium hydroxide is formed. So it is alkaline now. That's why the indicator is changing the color of the solution. So add a few drops of universal indicator to the content in the test tube. What color change do you observe? It should be one of those colors. It should be blue, purple, or at least dark green. So the calcium reacts vigorously and rapidly with water, giving out hydrogen gas in the process. The hydrogen gas extinguishes a lighted splint with a pop sound, as we said, and the calcium hydroxide is a white precipitate. You will find it as a white precipitate later. So the reaction between calcium and water is represented by this word equation. Please, this is calcium. If you write the word equation, this is calcium, not Ca. If you write the word equation, this is water, not H2O. This is an arrow, not equals. This is calcium hydroxide, not CaOH. Or please just write it and read the title of the question carefully. If it says write the word equation, write it in words, please. I think it's so simple. Just memorize it as it is. And I hope it's so simple. Okay, that was the reaction of metal with water. When they react with steam, some metals actually do not react with cold water. So they react with steam. So magnesium plus water or steam makes magnesium oxide. Do you notice something different here? Yes. Did you see here? Do you remember what we were saying? It's forming metal hydroxide with the water. What's going on here? It's oxide, not hydroxide. Why? Because it's reacting with the water steam, with the hot water vapor. That happens to magnesium, happens to zinc, and happens to iron. Copper, silver, and gold, they are the easiest, like it could be like the easiest question ever. You just say like they're less reactive, so they don't react with water or steam. So it's so easy for you to memorize this, I think. So you can make a magnesium reaction with steam. You make a wet filter paper to release the steam, to produce hot steam. It will pass you will pass it on a magnesium ribbon, and you need to give it some like heat or flame, so it will release or make magnesium oxide plus hydrogen. So let's have some like summary. Let's summarize some metals reactivity with water. For magnesium, it reacts slowly with water, reacts vigorously with steam. So if you want it to react faster or more vigorously, just make it react with steam, not with cold water. Sodium, it reacts vigorously with water and a flame is produced. Lead is no reaction with water or steam. Same as copper and silver and gold. Aluminum, it reacts with steam but not water. Calcium reacts vigorously with water and no flame is produced. So there is another summary of this also in the reactivity series lesson. It's almost the same as we said, but in a more organized way. Page 140. You have here potassium and sodium and lithium, by the way. They react very vigorously to form metal hydroxide and hydrogen. For calcium, it reacts vigorously, not very, just vigorously. That's for calcium. For magnesium, it reacts slowly in water to form metal hydroxide and water, and it reacts vigorously in steam. So if it's water, it will be slowly. If you want it to be a bit faster, you need to make it react with steam. And if it reacts with steam, it will not form metal hydroxide, it will form metal oxide. For aluminum, zinc, iron, they are the same here, so they react with steam but not with water. They form metal oxide and hydrogen. For lead and copper, they don't react at all with steam or water. For silver and gold, same, they don't react with steam or water. So lead, copper, silver, gold, no reaction with water or steam. I hope you understood the 7.2 lesson, and for any questions you can just ask me anytime. Thank you.